this lesson we're looking at exothermic and endothermic reactions. So far we've looked at a lot of different types of reactions, and what we're going to look at today is this concept that reactions can actually take in energy or give off energy. And previously we've seen in the earlier topic that energy is heat, or maybe it's a better way to say that heat is a form of energy. So if a reaction is taking in energy, then it's going to be cold. It's going to feel cold because it's absorbing all the energy from its surroundings. If it gives off a lot of energy, just like a heater gives out lots of energy, then it's going to make it really hot. Where this word endo and exothermic reactions come from is actually from Greek. It's Greek language. So endo comes from the Greek word endon, meaning within, and exo comes from the Greek word exo, which means outside. So we're talking about energy being given outside or being taken within. And that's where we talk about this exothermic and endothermic. So exothermic means that heat is given out. So the temperature outside goes up. Endothermic means that heat is taken in and the temperature outside goes down. So some examples of the two. An exothermic, we saw last lesson, burning gives off heat. You can get those little heat packs that you sort of crush and they get really hot. A candle flame is an exothermic, so again it's a type of burning. Actually making ice cubes sounds a bit weird, but making ice cubes gives off heat. Nuclear explosions, nuclear fission. Endothermic reactions, we have ice melting because it's taking in that thing, it's absorbing the surrounding heat, so it's going to warm up, but the outside, the surrounding environment will get colder. Wax melting, baking bread, evaporation is a good one, cooking an egg, and cold packs. So remember, anything that's taking in the energy from the surrounding, so the surrounding area is affected. Let's look at some exothermic reactions. So this means it releases energy, which makes them warm or hot to touch. Although the released energy is usually in the form of heat, sound, light, and electrical energy can also be produced. It doesn't just have to be heat. We will see some reactions where huge amounts of light and sound are given off, and we can also create chemical reactions that produce electricity. Other examples include burning a match, burning a log in a campfire, or the gummy bear experiment. And I'm going to show you the video of this, and I will set this up as a demo so you can see it in the class because it's a really cool experiment.
Stand by on 911. It's been a whole week since I've been on fire, but you know, today is a new day.
You've been fine. Hey, you know, I was talking to the kids about energy, and it's hard to teach kids about food having energy sometimes. And so I wanted a demonstration to be able to show this, and this is a classic. It's the gummy bear demonstration. Yeah. And what we have here is we have a powder that's been turned into a liquid. You'll see I'm using the blowtorch. We have to tell our viewers you don't do this at home. Right. Hold this up and show them if you don't mind. This is a powder. Stay away from here. Oh, this is a powder called potassium chlorate.
Do not hold the powder close to the flame.
Yes.
It's what?
Called potassium chlorate.
Oh, right.
Similar to that white stuff that's on the end of a match. You know, there's a red and a white stuff that's on the match.
Oh, right.
Yeah.
Sure.
So this is a strong oxidizer, meaning that when we liquefy it like this, it's ready for any organic to go inside, and we're going to call the gummy bear an organic. Oh, okay. So you know, you're a big runner. You know that you carb up before you run. Right. So gummy bears over here, and you can take a look at the gummy bears, make sure they're okay. So the gummy bears there are just regular old gummy bears who are full of a lot of energy. All right. So here's what we're going to do: is I'm going to put the gummy bears down inside here, and I want you to watch what happens. Ready? So
should I stand back?
If I were you, I would. Ready? So gummy bears go down inside like this.
Oh, gee.
Take a look at the tremendous amount of energy that's given off.
People
this
eat
fire.
These things.
Isn't that amazing? Now look, the fire is shooting out here. Look at all of this
gosh.
Energy being released by the gummy bears.
It's almost like jet propulsion.
Isn't that amazing? So when you're teaching kids that carbohydrates have a lot of energy, it's just the perfect fuel for this oxidizer.
Is that what they look like when I eat them?
Well, now you can run a little bit.
Oh my gosh.
The small amount of smoke that's going through the trees, not a big deal at all. Look at this one. This is one that we practiced with you. This one's a cool one, so you can touch this one. Look at the flask. You can really see the reaction that happens inside. So there's the chemical reaction that takes place inside. So literally we release that. It serves as a fuel, a strong oxidizer like that. And you have
cool.
experienced the famous screaming gummy bear lab.
I had no idea.
Absolutely
Can you
amazing.
this powder with the what is potassium? What
It was
was
called
in there?
potassium chloride.
Is
And
that
it's just a strong oxidizer.
That's something that
Yeah.
chemistry teachers would
Absolutely.
use
It's
in the classroom.
This is a classic in the chemistry classroom. See, I get to bring these to you because there's a lot of people.
So they call it the screaming gummy bear experiment. You couldn't really hear it in the video, but it's really interesting. When I show you this experiment, you'll see what I mean. It makes this really sort of almost like a kind of like a whistling noise, like something like a huge amount of air is shooting out of a tube, which you could sort of think of as like the gummy bears screaming as they're sort of like reacted through this huge exothermic process. So now we look at endothermic reactions. So this absorbs energy and makes them feel cold to the touch. However, it doesn't always have to be. So baking bread is an example of an endothermic reaction because it's absorbing the energy around it. But in that case, it's not cold to the touch. So this is the sort of confusion. And I'm sure when I gave you those early examples and I said something like freezing ice is exothermic, you were like, well, hang on. No, freezing ice doesn't get hot. But it's not actually about the temperature. The definition of endo and exothermic is about absorbing energy or emitting energy to the surrounding environment. That doesn't always have to translate to the thing being colder and the thing being hotter. Most of the time it does, but by its definition it doesn't have to be. So some other examples. Photosynthesis. So plants absorb sunlight, they make food. Chewing a mint gum. The heat energy from your mouth makes the mint feel cooler. So that's why, so that mint has that cooling effect. And the next one I'm going to show you. So that's a good example of an endothermic reaction. So in that case, we could see that it did get colder. This is a very similar reaction to what happens in your ice packs. You often have like a small pouch of a separate powder. You crush it and you sort of mix it all up so it integrates exactly like we saw in the video, and it gets very, very cold. So an example that I'm going to show you in a demonstration is potassium and water. So potassium and water is a bit of a unique reaction because potassium is a metal, but it's one of the metals that react with water. And what it does is it produces hydrogen gas. But it is so exothermic that it actually generates enough heat to ignite the hydrogen that it's producing as it's producing it. So it creates this illusion, well, sort of an illusion, sort of actually happening, of it burns in water. So you throw it in water, depending on what you use, sodium is not as good. Sodium often kind of fizzes and a little smoke. Potassium normally works a lot better and will actually ignite. And if you can get it to work properly, you get a good enough piece of potassium that's clean enough, it'll actually explode as that hydrogen just blows it apart. So it's really kind of interesting to see that you can put a metal in water and it actually will catch fire. So the reaction looks like this. You've got potassium, you add it to water, H2O. It produces this potassium hydroxide. So it actually makes the solution, what do you think, acidic? Basic. It's basic. It's a hydroxide. So it makes the solution basic and it produces hydrogen gas. And the hydrogen gas ignites from the heat of that exothermic reaction. So we'll see this in the demo. From here, we will do a quick little revision Kahoot on chemical reactions and we'll pick up next lesson.